The Hardware Capstone course allows students to work in groups on a single project that parallels the experience of working for a real company or customer. Students prototype a substantial project that mixes hardware, software, and communication components. This quarter, many of the students decided to focus on building computing technology for sustainability.
We are building a power strip and a 4-outlet device that can monitor and manage the power consumption of household appliances and reduce their power through turning them off when they're not in use.
So our chip is going to plug into the network, and you can see which devices are plugged in, which ones are turned on through the web portal. You can define patterns and rules. You can train new devices. So for instance, maybe you've got a TV at home, you've got a stereo system, and you've got a DVD player and maybe a Blu-ray player, right? So if the TV's off, none of those other things need to be on. It will actually shut off your home stereo system, your DVD player, your Blu-ray player, whatever else have you that's plugged in.
I'm working on getting values from our analog circuit and converting them into digital values and processing them. So here we have our analog circuit that John built, and we have a TI microcontroller chip that we're using to grab values from the analog circuit through its ADC.
So what I'm doing is essentially developing a protocol to talk from Dan's chip, from my chip. From there, my chip will be the one that decides, okay, we've seen a cell phone charger on port 3 and it's not drawing any current, so let's shut it off and things like that.
My job as the electrical engineer of the team is to take the power consumption behavior and make it into a signal that the microcontroller we're using can read. Since it can turn off devices that are wasting power, it can save people electricity and subsequently money.
So our project is Power Pulse Energy Harvesting and Monitoring System. This product allows you to measure your home or office power consumption in real time, and it does not require any batteries or wires. So just by informing people, we're hoping that that can achieve significant energy savings. When you know how much power you're using, you can be a little more conscientious about it. You can see, oh, if I just leave the TV on for 6 hours while I'm gone, it uses this many more kilowatts than it would otherwise. And the way it works is you take an inductor, which inductively couples with your circuit breaker, and that's what harvests power. So we collect the power, run it through a power management circuit, boost up the voltage so it's usable, and we use that to power a microprocessor that comes on periodically and samples data. And based on the charge time for the capacitor bank, we can infer information about how much energy is flown through the circuit breaker, which lets us periodically send data back to an access point and give you watts per hour, kilowatts per hour for your residential or office. I think even if the actual product here turns out to not be entirely useful, just knowing that it's possible to harvest energy in this way is a contribution to the academia in general.
This is the smart drive project. What we're doing is building, it's a 3-phase system. We're building a hardware device that will interface with the diagnostic support on your car and gather information in real time about your speed and the RPMs and oxygen sensors and fuel pump pressures and all of that. And from there, it's going to be uploaded via Bluetooth to an Android smartphone, tagged with GPS data, and then uploaded to a website where we'll analyze it and actually show you trip information and diagnostic information about your car. There are other devices that do similar things, but nothing that's as easy to use, or it will do the powerful trip analysis using GPS.
Is that, how would someone interact with the hardware to say, I only want to pull it every 10 seconds instead of every second, or is it just defaulted to?
No, we actually have a timer set, so the timer goes off every second, and that basically calls a function to get the data.
Okay, so it just goes every second.
Yeah,
and then you can plug it into a car and get some new, fresh.
Yeah, because I don't know how to feed data through here, and it's one of those things, well, is it worth it to get a bunch of data, get the format right, and get it dumped in here?
Yeah.
People who use the device that we're making can be able to know more information about the cars that they can use to save money in the long run.
Like this interface reads from the simulator once a second or so to see what kind of data is getting pulled, but it actually sends way more. Because you said you could see and it was sending a lot, right?
It was sending a whole buffer.
Yeah. I'm working on
coding for the microcontroller and our memory module.
I've learned that to actually start a project from scratch, it's a lot more complicated than it seems. It's not just like, oh, take a look at a few papers, just start writing. You actually have to do a lot of research and a lot of preparation, and documentation is really important, and organization is also really important.
Our PCB should be in about a week. We're going to get that sent off, and so hopefully in about a week and a half we will have a working prototype.
The number one reason you should do a capstone course is it allows you the freedom to work on your own project.
It definitely gives you a lot of experience.